Hi guys, today we are going to see LeetCode problem number 197, rising temperature. Marked as easy, so directly go to the problem statement, try to understand it and solve it. So at the beginning of the problem they have provided the SQL schema so that you can copy this one, and if you want to create the table you can paste on your own SQL platform and create the table by your own to try to solve this problem by your own. Okay. So let's see what they have provided in the problem statement. They have provided the table weather contains column ID, record date and temperature, and these are the data types provided. ID is the primary key for this table. This table contains information about the temperature of a certain day. Okay. So write an SQL query to find all dates ID. So output should be ID with higher temperature compared to its previous dates yesterday, and we can return our results in any order. Okay, let's check an example to understand this problem more efficiently. So this is the weather table, input table. These are the IDs 1 2 3 4, and these are the record dates, and these are the temperature recorded on that particular day. So what you have to find out, we have to find the ID, only those IDs on which the temperature on that particular day was higher as compared to its previous day. So if we compare the first ID1, this date and temperature 10, but we don't have any dates before that, so we'll skip this one. We'll check ID2. It has temperature of 25. It is higher than previous day, higher than yesterday, so this ID will come in our output. Next, check ID3. This date and has temperature of 20. It is lower than previous day, so it won't come in our output. Now let's check ID4. It has temperature of 30. On that day, particular day, temperature is 30, so it is higher than previous day's temperature, so this will come in our output. So ID 2 and 4 will come in our output. Let's see ID 2 and 4. Okay, so we understood the problem statement and what you have to do. So let's go to the query writing section to build our query. So there's quite a few ways to solve this problem. Uh, there is a Windows function as well, through which we can use this one, lag or lead, and also we can solve it by using join. So first of all, let's try to solve this problem by using join. So select uh, ID from weather. Let's give this weather as a. Now we have to check, compare this temperature within this table only. So in this case we have to use self join. Okay, so weather A, this is the alias for this one. Join again, we're going to solve self join to this table B. and 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 on what condition we're going to uh, join this. We're going to use the join condition so that we can compare the difference between two dates. Two record date is one, so there is one SQL function date diff. So date diff will do, it is going to uh, compare the two record dates. It is going to uh, compare the two dates and give us a result. Okay, so just check, it takes three things. Just check the index, the syntax in here for date diff. So the first thing is, what is the difference quantity we want? It is day, month or year, so we want day. And why day? Because we just want to check the difference between two record dates should be one, because they have mentioned that yesterday. So there is a possibility it can happen that in this record is not present here. So in that case 1 3 4, so we won't compare this temperature with this temperature. We will definitely check this temperature with 2, or else we won't check this temperature with its previous date. Okay, so luckily we got this record date in sequential order with 1 2 3 4, so that we can compare with their previous days. But in any scenario it can happen that the previous dates data is missing, so in this case we need to use date diff. Okay, so date, and we're going to give two conditions, two different record dates in here. Okay, so let's give one record date. For an example, as we are doing this self join, what we're going to get, we are going to do this comparing the record dates that is 1, and we are going to write a condition so that the temperature is higher as compared to the previous day. Okay, so this table, you can say the data of today's today's record date and temperature, and whether P is the uh, record date and temperature of yesterday's data. You can imagine like that, and that's the way I am writing this query. So b dot record date, and here I will write a dot record date, okay, equal to 1, because we want date difference with using day as 1. Okay, now if we run this query in here, we have to actually give one more thing in here. Instead of id, let's give star refer for this time being to see all the results which we get, and then we'll write what the according to the output. Now here you can see the first record. So between these two record dates, the day difference is 1, therefore this record will appear. You can see 2 and this date 25, and the join condition satisfies, that's why this record will also appear, that is yesterday's data. You can see 1 and then 2015 1 and 10. Then again difference between these two dates is 1, therefore this join condition satisfied, therefore this data will come in our output table. And this also you can see 3 2015 1 0 3 20 and 20 20, and then 2 and this whole record, 2 and this whole record, sorry, 2 and this whole record, 25 temperature 25. And finally we are going to check this record and see these two record dates difference is 1, so this record and this record will appear in here. So 4 2015 01 04 30, and then 3 2015 01 03 and 20, 3 2015 3 2015 01 03 and 20. Okay, now what we need to do, we need to just give a last condition in here to compare, where so a is our today's temperature, and a table a what we are considering right now, and b is our yesterday's one. Okay, so a dot temperature is greater than b dot temperature. Okay, and in output what we need, the id, and id from which table, which days, find all dates id with higher temperature compared to speed, higher temperature, that means today's, that means it will come as a dot. Okay, let's try to run this and see if it works or not. Yeah, We can see our query ran perfectly and it is giving the correct result. Now we can submit our query to check on other test cases. Yes, it works perfectly fine and very optimized, and it is faster than 98.06% of MS SQL Server online submissions. Okay, so this is one way through which you can do it by using self join, and there is another way by using window functions you can do it. Let me show you that also. That is using lag or lead. Okay, so let's try to create that other query. So what lag and lead does, I'm going to use lag in here. So what lag will do, for an example, we have to compare these two temperatures in here as well as these two dates. So why not we create another column in here? Just for an example, right now, just think for temperature in here. We are creating a temperature duplicate column, and we can put this 10 value in here, 25 value in the record of 3 just beside. This will come in here, this 25 will come beside 20 and 20 will come beside 30, and we can compare these two columns to check if the temperature is higher or not. That's the logic for lag. Okay, let's see, we are keeping everything and we are writing the lag. Just check the syntax of lag, and which column we are targeting for lag, temperature, and how much lag. Because if I give lag of 1, then it will leave this column and it will go in here. If we give 2, then it will leave this and this, and it will directly come beside 20. So we just want to compare with the next day. Okay, so we'll give lag 1, and we have to write over. This is the syntax how it works, and order by record date. Okay, it can happen that they have provided the data of 250102 before 250101. Then if we don't use order by, it can create a problem while comparing the temperature. So we have to order the record date with ascending. So ascending is default, so we don't need to write ascending in here. Let's give it a alias. It's column name, it's temp lag table. Okay, and we just did it for temperature. We also need to do it for record date as well. Okay, so just copy this one, paste. So lag record date, and again lag 1, order by record date. Okay, as, let's give it a name of rec record lag. Okay, now this much is done. From which table? From weather table, and we have to give the condition where. Now we have to compare two different things in here, the record date as well as the temperature. Okay, so now just you can imagine this 10 came beside 25. I can do one thing, I can just like run the query till now to show you what will be the output. Okay, let's see the output now. Okay, now you can see the headers in here in our output: id, record date, temperature, and temp lag, record lag. Now see, first column, it doesn't have anything above it, that's why it will be null. Now the second, sorry, not first column, first record. Now the second record, 2 20150102, 2 20150102, and 25. Now 10 will come beside it. Just check, 10 came beside it, and this record which was beside which was the record date of previous day, it will come in here. Okay, this 10 and 2015010. Same will happen with other records as well. You can see 3, this record, and these two records will come beside it. 25, 25, sorry, 25 and 2015010, 25 to 0. So it will be very easy right now to compare these record dates and temperature, because we have created our own column. Okay, so let's write the rest part of the query, where temperature is greater than our temp lag. Okay, and another condition should be about the record dates. It will be the same like the previous date diff. Now we are going to do it with two different tables which we have created. Date diff of day, the difference measurement, and what we're going to do, the column we created, rec underscore lag, and another is record date. Okay, and which should be equal to 1. Okay, so that's the query which we need to run to get our expected result. Let's run it and see if it is giving the expected result or not. Okay, so we are getting invalid column name, temp lag. Okay, I got it. So what it is trying to do, because we have given this conditions aliases in here, so when we are writing this where condition, it is not going to take the alias. For that we need to write subquery. Okay, it's nothing something very serious error in here. So the table which we have created, we are just putting it in our main query, and we are just writing a subquery. Also we need to keep in mind that we just need the ID. So just write the ID from this query, just give it a alias a, where these conditions. Okay, looks tidier. Let's run this query now. Yeah, and it works fine. So let's try to submit it to check for other test cases, and it worked perfectly. You can see this query is very optimized, only taking 657 milliseconds and faster than 99.30% of MS SQL Server online submissions. So you can use both the queries to get this expected output, but for this problem, subqueries always takes a little bit more time, but join is more, I would say, fast. Both will give you the same result. Okay, so try it by your own and let me know if you have any doubts or anything. I'll give the descriptions and solutions in the solutions in below in the video description. You can get it from there and try it by your own. I'll come up with another LeetCode problem. Till then, bye and happy coding.